Hello, brilliant researchers. In this video, we gonna introduce our project idea, working principles and the project parts in a very short summarized animation. This project is some kind of compressed air energy storage techniques and plants. The main idea is almost the same as pumped hydroelectric power plants in terms of their applications, output and storage capacity. But instead of pumping water from a lower to an upper tank during periods of excess power, ambient air is compressed and stored under pressure in an underground vessel. When electricity is required, the pressurized air is heated exactly like a gas turbine plant in the solar collector and expanded in an expansion turbine driving coupled with a generator for power production. The project involves some differences over the usual plants of compressed air storage. It utilizes the motion of cars and trucks over an artificial special designed bump to convert this motion into pressurized air in an underground cavern. Unlike other plants, a compressor is used to compress air at first. Then, when power is needed, the compressed air is released, passing through a gas turbine, which in turn is coupled with an electric generator to produce electricity. So, in this type of energy storage, no external power needed or electricity to compress the air. You just make an advantage from the motion of cars over a bump to produce electricity if needed. So, let us discuss the working principle. When the car or the truck moves over the artificial bump, it applies downward forces with values equals a fraction of the weights. These forces push the bump, cylinder rod and piston down as they are all linked together. The intake port is attached with a non-return valve from inside to let the air in, but not the vice versa. When the aforementioned assembly moves down, air is compressed and enters the pressurized underground tank. This process is repeated twice with each car movement. When the front wheels are above the bump, it goes down and up again using the springs attached. And when the rear wheels moves up the bump, it also goes down and up again. Back to the compressed air when it reaches a certain value, which is specified by the pressure relief valve. When the PRV opens, air is released to the piping system, leading towards the gas turbine. We may use electric heaters to increase the kinetic energy of the air, or we can use solar concentrators, so that it can lead to more power exchange between blades and compressed air. Then more power is generated. We can use a unit gas turbine for each bump, so the bumps can work and produce power in parallel, but hence the cost will be extremely higher. Or use a network of pipes that connects several bumps in many roads to a main final pipe, which in turn is connected to a huge gas turbine. The last configuration can ensure that the energy production is semi-continuous and not intermittent. When turbine turns with a specific speed, it turns a generator. So, the selection of appropriate generator is important for low speeds. Synchronous generators are used. Project parts. 1. Artificial bumps. Speed bumps are the common name for a family of traffic calming devices that use vertical deflection to slow motor vehicle traffic in order to improve safety conditions. 2. Pneumatic cylinder. Pneumatic cylinder are mechanical devices which use the power of compressed gas. 3. Springs. A spring is an elastic object that stores mechanical energy. 4. Pressure vessel. 5. Relief valves and non-return valves. 6. Solar concentrators and piping. Linear parabolic trough is a type of solar thermal collector that is straight in one dimension and curved as a parabola in the other. 7. Gas turbine or iso-rotary machine that converts kinetic energy and potential energy of water into mechanical work. Thank you for paying attention.